So there are three different types of equations, linear equations. And so one of the things they ask us to do sometimes is to classify the equations. The first type of equation is one we're kind of used to seeing, something like x plus 3 equals 7. That's called a conditional equation. It's only true, that statement's only true if x equals 4. And so there's a solution, one solution to that equation, and it's not a true equation or a false equation. It's dependent on the value of x. If x equals 4, it's true. If x equals something else, then it's not true. And so it's called a conditional equation because it's based on the condition of x. Okay, it's based on another condition. An identity, okay, something like x plus 5 equals x plus 5. Well, that's true no matter what. If you take any number, any real number, and add 5 to it, it's going to equal if you take that same number and add 5 to it. So it doesn't matter what x is, it's always going to be true. And so that's why it's called an identity. So a lot of times, though, they'll want to know what the solution is. Well, it's true for all real numbers for x. And so we can say, sometimes they'll write, the solution is all real numbers. This is always true, by the way. And it's not dependent on the value of x. It's always going to be true. And we write we can say all real numbers, solution, all real numbers. Sometimes books will say that. But if we write it in interval notation, it's written from negative infinity to infinity. And so that's the interval notation that represents all real numbers. So you think of a real number and plug it in for x, and it's going to make that statement true. Now, the other type is something like if you have x plus 3 equals x plus 7. Well, that's going to be a false statement no matter what. It's always false. And so a lot of times, though, they want to know the solution. Well, the solution is the empty set. And you can write the empty set with a 0 with a line through it. So that represents the empty set. Or you can say the empty set that way with braces without anything in it. Or sometimes they'll write no solution. So you can think of values for x all day, but that statement's never going to be true. You take a value and you add 3 to it, it's not going to equal if you take that same value and add 7 to it. And that's why it's called a contradiction, because it is never going to be a true statement. Okay, so now we have some examples where they want us to classify and solve. So this first equation, a really long equation, gives us some practice. We're going to go ahead and distribute. So we get 8 minus 24x plus, we'll distribute again, 30x plus, what's 7 times 15? 105? I think it's 105. And then we're distributing the 2x plus 100. We're distributing the 4x plus 12 plus that 1. Okay, so a lot of distributing. Now we're going to look for some like terms to gather up. So we have a negative 24x and a 30x, that's going to be 6x, plus, and then we have this 8 and the 105, that's going to be 113. And then on the other side, we have a 2x and a 4x, that's 6x. Then we have 112 plus another 1, that's also going to be 113. So right there, you could stop and say this is an identity. And you'd be right, that'd be the classification. Sometimes students, though, they get so involved in solving it, they're like, no, I'm going to get x on one side, I know I'm supposed to do that. And they get this, which is fine, we didn't do anything wrong. You could say it's an identity at that point, because 113 does equal 113. Sometimes, though, an error is made, the students are like, oh no, I don't have an x, and they try to like squeeze one in. No, don't do that, because then you're going to get a solution and that's not going to be right. So you're going to make it a conditional equation, and it's not. This is an identity, okay? So, and sometimes too, students will like, nope, I'm going to subtract 113 from both sides. You can do that too, but we already know it's an identity. You get 0 equals 0, which is still true, right? So it was true here, it was true here, and it was true up here. All of those make it an identity, but the solution, because it says classify, we did that, it's an identity, and solve. So the solution set's going to be all real numbers, negative infinity to infinity. We're going to write our solution in interval notation. All right, so now we have 2 more examples, classify and solve. These are a little bit shorter, it looks like. So distributing the 11, I get 11q plus 33 minus 5 equals 19. Okay, so I got 11q plus 28 equals 19. That look right. And subtract the 28. So I get 11q equals 9, negative 9. That looks right to me. And you have to divide by 11, which that's okay. So we get q equals negative 9 over 11. So they might put it this way, they might put it in set notation, but we're just getting one solution here. This then is a conditional equation. So the classification is that it's conditional, and the solution is negative 9 over 11. There's only one answer, and there's only one value that will make that statement true, and it's negative 9 over 11. All right, so we've got one more here. We have 12c. We have to distribute plus 25 plus 15c equals 27c minus 12. Okay, so we have 27c plus 25 equals 27c minus 12. Now at that point, you see that the 27c is the same on both sides. So you could say that this is a contradiction. So it's a contradiction. Contradiction. You can subtract the 27c from both sides. I mean, if you wanted to keep going, there's really no need to keep going, but I just want to show you what sometimes students do, so like if it happens to you, you won't be surprised. So what happens is the c's cancel out there, and the c's cancel out there, and so you get 25 equals negative 12, which that's not true, that's false. And so it makes it a contradiction, and so there's no solution, there's no value here that will make the statement true.